Hey, sup? It's been a while. How's everybody doing today? Let's get some music going. That's probably good. Let's see, how do I want to do this? Okay. Alright, so if you are just joining the stream or just checking out my channel, you're not too familiar with who I am, I'm somebody who likes to make games. Yeah, it's basically a hobby of mine. And so what I'm going to do today is work on this collision library that I had been working on in attempts to basically make it a little nicer. Currently it's not bad, but it could be improved. The thing that, well, I'll show what I have here. It's there's a link in the description, but it's up on GitHub. That's fine. So basically, it's a library for arcade game collision detection and resolution, and this is a video that basically shows a little GIF that shows what it does. It just allows for really solid collision detection and resolution without really too many cases or any cases of things slipping through things or anything like that. And this was created because I actually talk about it here, but like basically when you make games, when I make games, it's something that I walk into sometimes where you try to make something maybe with a framework or something like that, and it's pretty easy going, but then you get to the stage of like trying to do collision and it's like what do I do? How do I do this? So basically the idea behind this is it's not a full physics engine. This doesn't do things for you like gravity. It doesn't do things for you like friction. It doesn't do things for you like double jumps or flying or any real movement mechanics. It just allows you to easily check to see if you're touching something that you don't want to touch or want to touch, or if you're touching something, it allows you to move into contact with it. So that's kind of the point, is just make it a little easier to go ahead and do physics, essentially. And so this is the basic idea of the old version of resolv. That's the name of the library. You create a couple of rectangles, and then you can just check to see if they collide, or if you try to move one into another one, if it's colliding, and then move it to touch, essentially. And then the slightly more advanced one is basically creating a space and then adding shapes to the space and checking against that space. So it's pretty straightforward. Either way you go, the API is really clean. I want to keep that and make it really nice and easy to use. So the current situation is I'm trying to basically make it so that you can go ahead and use for one X and Y speeds as the actual speeds rather than a speed value and whether it's on the x-axis or not. And then also I'm trying to switch this around a little bit so that if you do use X and Y speeds together, it tries to basically like approach a collision in steps, and then as it goes along it goes ahead and moves toward the collision in steps according to basically the speed that you put in. So for example, if you put in a speed of, let's say, 10 down, it should basically do 10 steps and move the object slowly on those 10 steps until it comes into contact with the object and then says, okay, that was the last frame essentially that it could go ahead and collide. So that's an idea. I have to work on it a little bit. I might switch this around because the core concept isn't bad, but it's not really great. A better approach, I think, would be to go ahead and essentially, let's see. Yeah, okay. So yeah, I think that a better approach would probably be to go ahead and essentially start at the end and then move backward until it's no longer colliding. Because the current approach kind of necessitates, like, it's going to move at the number of steps no matter what. It's going to move at 10 steps. If you're trying to move 10 pixels over, it's going to move 10 times. It's going to test 10 times rather than just testing once and seeing if it basically is running into something. And then on top of that, it's a little awkward to approach it from this direction. It's not really made to work the way that it's working right here. So I think that, I mean, it doesn't really work that well in this current incarnation. Yeah, it's just straight up phasing through stuff right now. Let's see, it might be this code. Really the only reason I don't want to make it so that it starts at the end and moves back is because when you do that, that means that it's possible to phase through things, and I don't want that to be a possibility unless you basically force that. So basically, I don't like the idea of if you're moving fast enough, it will just phase through. Maybe there's another way to do it. Where maybe you have like a outer collision resolution function or something. I'm trying to figure out another way to do it where maybe you can say, okay, well, I want to check this, maybe this collision, maybe like break it up into different pieces and then go backwards. I don't know. I have to figure out basically if I want to allow that. And the idea is basically tunneling. That's the idea, is tunneling. So maybe I should make something specifically for tunneling, because the only real situation where something could tunnel is if this square was moving, the blue square, and it was moving at a rate larger than 16. So in order for it to tunnel into something, it would have to be moving at, let's say, 32 pixels. Let's say that all the collision objects are at least 16 pixels wide. It would have to be moving 32 pixels per frame, which is absolutely insanely fast. And even 16 pixels per frame is something that the resolve function would catch, because it would move forward 16 pixels, see there's a collision, and then start moving back until it's no longer a collision. So 16 pixels, or one body length of a collision body, isn't that big. Tunneling would only really happen at insane speeds. So maybe I would make something specifically to handle tunneling, and just make the basic resolve function easy to use and easy to kind of comprehend. So that's probably what we'll do first. We'll start that. So we'll take out these started free, ended free. Excuse me, started free, ended free. We'll take that out. It's just a collision. If the other object that it's trying to collide with isn't collidable, then that's fine. There wasn't a collision. Actually, this is incorrect, because if it's not collidable, then it should basically... Yeah, it's not quite right. Alright, let's go ahead and squeeze this out. Okay, so here's what we're going to do. We're going to just rewrite this entire thing. Well, not the entire thing. Most of it. We'll rewrite part of it. Okay, so basically the idea is, well, let's just go like that, and just, what, because I do want to keep the idea I have here if this doesn't work, so we'll do it like this, because we don't want to destroy code. Yeah, we'll keep that. Alright, so we'll just do this. We'll copy this function, resolve, and turn it into, a comment. And then we'll just go ahead and, mush this entire thing. There we go. Okay. We'll keep this because we probably would want that, but anyway, what we're gonna do here is basically when the resolve function runs, it basically should say, hey, did it collide with something? If so, how far should I move? If not, then the resolve x and y should be basically the distance, right? The resolve x and y should be the distance that it was trying to move. So let's see, so you say I will pass the x speed in. Okay, so this wouldn't be resolved then, this would be flow 32, okay. So basically you say, yeah, the endpoint of the collision. Well, I guess the in32 is fine. We'll just do like that. Okay, so what we do is a pretty simple loop where we say colliding equals true. And we say for colliding, if first shape dot is colliding, other else colliding is false. Okay, so this is basically a for loop where we're looking to see if it's ever going to not collide, essentially. We're not going to keep this because this would basically force you to loop backwards. Well, let's keep this for now. Let's keep this for now and see how this goes. Because at some point it's gonna not collide. So this is fine. This is fine. So we say if the first shape is colliding with the other shape at any point in time, then we want to move the first shape back. So we want to say the x and y are these, and then we want to say first shape dot set xy xy. Okay. Now what we want to do is move the x and y minus x speed, right? Now this isn't exact because we don't want it to move the entirety of the speed. We want to move it back one pixel or one step. So I guess there's a couple of ways we can do this. One would be to assume that you want one pixel back. The other is to assume that you want one. Let's see. One is to assume one pixel back, the other is to basically allow you to say how many steps you want in your game. So you can say, oh, I want, so if I walk up against the wall, it'll put me back 2 pixels or something. We'll assume 1 pixel because that's, I mean, what else would you want, right? P Mendez 99, La Consola, and Rashad Z says, oh, hi there, hi and yo. Yo, what's up, how's it going? So we'll move back by 1 pixel. What we want to do though is this. So let's move this out. Get x and y are integers, so we want to actually turn these into floats. That way we can actually like do something with the x and y there. And we want to convert this to values as well. Okay. There we go. Alright, so we want to move it back by x speed and y speed, but we want this to be basically a pixel. Like, so this is kind of the hard part, because it's like, okay, let's say that your x speed is 10 and your y speed is 1. So you want it to move basically back 1 on the x-axis, but 1/10 on the y-axis. So it should be 1 over, maybe. But that's not right. We want it to be a slope. So the slope is x speed divided by y speed. So if your speed, x speed is 10, well, let's say your x speed is 1 and your y speed is 10. That's 1/10. Right? 1/10. 1/10. X speed is 1. Y speed is 10, so that's 1/10. That means that for every x speed is 1. Y speed. That means for every y value gained, your x should advance by 0.1. Okay, so we just say times. Okay, so we can say 1 here, and then slope. That's if the x. But see, that slope isn't quite right. That's assuming, yeah, well, we need, okay, this is where it gets a little tough, because we need it to be a slope here. So let's actually print out the slope. Okay, so the slope is the x speed divided by the y speed. So if the So I guess it's hard because basically we want it to advance by 1 pixel on one axis and a percentage of a pixel on the other axis. So how do we determine that? So we want it to advance by 1 on the maximum axis, right? And a percentage on the minimum axis. So let's say max equals math.abs math.max math.abs x speed math.abs y speed. Oh, float 64. Mariana Suluboy says, "Hi, how's it going? Thanks for stopping by the stream here." Okay, so that's the maximum between the x speed and the y speed. So that's basically which is the bigger axis, the x-axis or the y-axis. But here's the thing, we don't know. We don't know which is the greater axis, so this won't help. This might help. The absolute values. Let's see. Okay, so this would say, oh, it's actually the other way around. So this basically says, okay, the prime axis is either the x-axis or the y-axis. So then slope could be this. So the prime axis is, actually I like it better the other way like this. So the prime axis is the x-axis, then the slope would be x divided by y. Let's see. So if you're running at 10x and 1y, 10 divided by 1, it should be y speed divided by x. So now it's 1 divided by 10, 1/10. And then it's the other way like that. Okay. Alright, so I think that's right. So we could say, okay, if the prime axis is 0, I guess we could just say prime x equals true. Prime x equals false. So we could say if prime x is true, then we subtract from x 1 and subtract from y a percentage. The slope. But if it's the other way, then we subtract it from x. Okay. Alright. So x, let's see. If prime x minus equal, oh, it's up here. If prime x minus equal y speed, x1, slope, else x slope, y minus equal 1. Oh, let's see, minus. Okay, then it sets it to x. Mariano says, be careful with x equals 0 and y equals 0. Yeah, I guess that's true. If other dot... Yeah, what we'll do is just something like this. If other dot is collidable, or x speed is equal to 0, and y speed is equal to 0, return out. Oops. Okay, so that should basically kick us out if we have a situation where there's 0 there. So, oh wait, Meryl says because division by 0, yeah, division by 0 will crash. So y speed 0 divided by 1, or 1 divided by 0. Yeah, that's true. Okay, so I guess we'll just do it like this. Slope is that. Alright, I think I'm on the right track. So move back and then gliding is false. Dot resolve x equal 32x. Dot resolve 32. Okay, so I think that's it. We don't need this anymore. What's up here? Alright, that might be everything. Prime x, prime y, prime x, prime x, prime x, where's that? Okay. Okay. Even if y is bigger, yeah, okay, so if y speed is equal to 0, okay, so basically if y speed or x speed is equal to 0, then slope will just default. All right, I think this might work. Let's see where we're at with this. Oops. Nothing yet. Let's see. Okay, so that is running. Let's see. Alright, let's get the x-axis out for now, just so we can see exactly what's going on. Alright, so it's never colliding, it looks like. Let's take a quick look at this. Okay, so it's never returning anything, so why is this not returning the values I'm putting in? Resolve x equals in32 x speed. Resolve x, resolve y, first speed y. Alright, so yeah, that's definitely there. Resolve x, resolve y. If other dot is collidable, or Alright, so out is definitely stuff here, but once we actually run this, it's not... Am I redefining out somewhere? Out, return out. It's weird, it should definitely... Mariano says, is the not including the or? No, the not doesn't include the or. The not, if it's not collidable or the x and y speed are 0, then we return early, because basically you're trying to resolve a collision and you're not giving any speeds. So it's like, well, it's not gonna move, so. And it doesn't know which way to resolve backwards either. This is weird. We're setting the variables, but once we return the object out, it doesn't actually go anywhere. Let's close some stuff, so I'm looking at it square. Okay, space.resolve. Oh wait, space.resolve, okay. So space.resolve is... Oh, okay. So it only returns if it actually is colliding. Okay. Okay. Alright, for now, let's just do this. No, that won't work, will it? Because it doesn't know what to check against. Okay, let's go back. Okay, so assuming that we're doing everything correctly. Okay, yeah, so assuming that we're doing everything correctly, we say out dot call other shape equals other. Let's see. Alright, I think we might be on the right track because it's not fading out anymore. Okay, so I think we just gotta do it like this. Alright, that's good. It's not fading out, but it is like giving extra height. I think it has to be like probably +1. Yeah, +1. Let's try that. So I can see exactly. Nope. No, it's just now it's just fading through it. Alright, so that's not it. So it should be the resolve Y should be the resolve position. Okay, so I think it's working correct. Oh, I had keys in here, ability in here to like slow it down. Oh yeah, I do. Okay, it's 1 and 2. All right, so yeah, it's going down too far into the actual thing. So why is the Y so low? Okay, so let me think about this loop. So it checks to see if it's colliding, and if so, moves it back. I guess what it needs to do is move it, because it's okay. So it gets wait. Yeah, when do I never. Oh. Yeah, okay, I need to move it to the target location first. I don't know why I didn't do that first. First shape dot set xy xv plus int32 x speed yv plus int32 y speed. I think that's what we're looking for. Yeah, it looks like it's coming in contact. It's bouncing higher. That's not good. That's not consistent. It's getting bounces. So let's try that again. What we did before, where we subtracted 1. It's still getting height. Yeah, it's still getting higher. That's no good. And it is plus, right? That's... Wait a second. Yeah, okay. I think it's definitely coming into contact. That's good, but I think there's something that needs to be done here. It might be this. That's how I had it set up initially, I think. Alright, that's better. It's always bouncing the same height. That's good. That's good. Let's do a test real quick where we actually like make it so that it loses its energy as it bounces. Okay, so it does come to rest on it. That's good. Eventually, it's just not enough to actually move it. Okay, so I think we might be on the right track here. Let's try adding in the x-axis and seeing if we get anything. Alright, so we're still bouncing. That's good. Okay. Alright, x-axis ain't working. Let's see. What do we wanna basically mimic this. Oh, that's what's going on here. It should be equals. Okay. Better for the right angle, but it's disappearing when it comes to the left angle. I wonder why that is. Let's do a quick check here to see what the resolv x is being set as when that happens. Beep. Okay, so 287. So what's this when it happens? -16, -17. So it's just kicking through it. We don't want that. What we want is... Oh, x is minus... Oh. Oh, yeah, we have minus here. We need it to be basically the negative according to the direction that it's moving. So that's fun. So basically we say if x speed is greater than 0, else x plus plus. If y speed is greater than 0, else y plus plus. plus if x speed is greater than 0, it's slope else, else 1 plus the slope. Alright, I think that might be it. Hey! I think it's working? Yeah, I think it's working. It's kind of tense because like you feel like it's gonna lose energy. That's pretty bananas. Did you see that? Did you see that? That's actually like really bananas that that actually works. It bounces under here and maintains 100% of its energy, even though it's not able to actually bounce. That's crazy, and it just pops out like no big deal. That's actually what is like exactly because I mean like if you used like Box 2D or something, it might lose energy in that situation. It might actually lose energy. But like the fact that it can basically maintain the energy as it's passing through that tunnel, that's actually kind of crazy. And it just kind of like shoot, boop, and it just keeps bouncing. And that's complete. Like, that's all the code you have to do for your game to do that is this. You can even cut that out. You can. It's just this. Now, if we do this, because basically it's losing energy as it bounces, or gaining energy rather as it bounces, because it reverses it. It moves it to resolve and then reverses it and then adds the speed. So it's getting more energy. Wait. Yeah, it's actually slowly gaining energy. This is good. This is a good test, though. At least now I can see like if it's actually. Yeah, so far no problems yet. All right, this is good. This is good. Let's undo that, and we should be good to go, basically. The next, I guess, let's try a couple of different worlds here. Oops. Alright, I think I changed some stuff with this. Yeah, now it's not distance, it's X. Okay, and main. Let's go to main. Let's change this to the second world. Okay, that works. Oh, that's not good. Let's see. Alright, that's good. That's not. That's good. Okay, so for some reason the left, it's not properly resolving. Let's see. Is the resolve X changing? Okay, the resolve X is always 17. That's right, yeah? That's right, isn't it? 0 to wait. Yeah, it's alternating between 17 and 16. Okay. So 17 is where it's saying it should be, and 16 is where. So why is it saying 17 then? It should be saying 16 if that's the edge of the wall. It's always saying 17. Okay. So then let's go ahead and go back to resolve. I think that it might be like... I think it might be cutting short, maybe... Because it says, if you're colliding, then move it back. Actually, we can do this a little more succinctly, like this. So it says, if you're colliding, move back. And then it says, if you're not colliding, then set colliding to be false and return the out. That kicks you out the loop. So I think the problem is that the resolve X should be... Let's see. Prime X, X be greater than 0, X minus minus, else X plus plus. And Y minus minus, else Y plus plus. Oh, Mariano says bodies usually have a bounciness property which you set to 1 as far as I can see. Yeah, I just have it set to 1 as a example to just maintain the bounciness in the other test. In this one, I'm trying to see exactly why it's giving 17 instead of 16. Does it ever actually... Let's see. Okay, so it actually does give... $16, 120, 16, 120, 16, 120, 15, 120, 17, 120. Oh, that's the first shape. Okay. So I think it's just not setting it at the end. I think it does this, sets the X and Y, and then tests it again. It fails. There's no collision, so then it says colliding is false. Why is it saying 17? First shape, X and Y. Oh, I guess that is the value that it's getting. But why should it not be 16? Why is it 17? Alright, let's try this. Let's try that. Alright, that's better. But, yeah, now that's not working correctly. Whoa, what the heck? Yeah, okay, well now you can zip, that's nice. That you can actually zip through the game. Like, I go in, and then you press left and it kicks you over to the right side of the body, that's cool. Like, I have like no problems with that, but yeah, this is kind of strange. Okay, wait. That's... Oh. Oh, yeah, and resolve X and Y are always going to be greater. than 0 because it's the actual x and y value. It's not the displacement. So yeah, it might be better to return the displacement rather than the endpoint, because the displacement, you can add it, but that also gives you the direction more easily. Alright, so we can't do this directly. It has to be... Captain Boomerang says, "Hello, just thought I'd swing by. What's this project about?" Basically, this is a project to allow you to easily do physics and things. It's mainly made for collision testing and resolution. So when you go up against a wall, it'll kick you back to the wall. It'll allow you to check to see if you're intersecting with another shape, stuff like that. Because basically, when it comes to physics, with like arcade games and things like that, it's one of those things that's kind of hard. At least for me, I always kind of struggle with the concept of physics and things. And when you get something complex in the mix, like Box 2D or Roll It, things like that, it can be more than you really need, especially if you're doing just kind of like a simple 2D action game or platformer. So basically, what I've been working on is this library called resolv, which is basically made to allow you to do the physics yourself and just do collision testing and collision resolution. That's the basic idea. So like, I'll show an example here. The previous example. In this example, we have a box that basically moves around. Actually, let's fix this a little bit because it was supposed to be higher up. It was 64. Okay. So you have this box that bounces around and it, collides with things and bounces around, and this is something that you don't need a physics engine to do. You just need to basically have something that allows you to do intersection and resolution. And so that's what the point of the project is, to make it more easy to do collision intersection, collision resolution, things like that. And then you would code in the actual physics. And this is kind of like one of the main parts of game design, game development, is physics. What happens when you jump on something, what happens when you run into something, how all that works. And yeah, it's something that should be, a lot of game engines, like a game framework can give you a lot of cool features, but I feel like this is something that a lot of frameworks really need to kind of focus on. It doesn't have to be super complex. What I have here is really simple. It doesn't need you don't need a full physics engine or physics framework or anything. You just need something that allows you to see if something is colliding and allow you to make a decision if it is. That's kind of it. So this is working pretty well, but once we're doing kind of a controlled test, that's where things kind of break down, and that's what we're working on right now. A little bit is breaking down a little bit. Let's go back over to here, because if we actually do have something that we can control manually, it gets kind of stuck when we're moving against certain objects. Only on the x-axis. So I'm trying to solve that, so that basically when you walk into something, it doesn't shuffle like that. For some reason, it's returning a value on the x-axis that's a little bit over from where it should be. The resolv x in this case is like 17 instead of 16, which would be right up against the wall here. Captain Boomerang says, "That's super cool. Thank you." Yeah, I feel like it's one of those things that's like, if I do it right, where it's not super invasive, it's super simple, it's something that should be able to be reused for lots of different projects, lots of different use cases, and that isn't a full physics engine. It should allow you to basically make your own like custom physics. It shouldn't feel like, oh yeah, this was made with Box 2D. Oh yeah, this was made with Bullet. It should feel like, oh yeah, this is just the game. Just like Mario and Mega Man, their physics feel like Mario and Mega Man. They don't feel like a core physics engine that got reused. Although Capcom games tend to, you could tell, there's polish and stuff, but I feel like the physics kind of have some similarities in Capcom like NES titles. Because they probably use the same physics engine, but that should be their choice. It shouldn't be where it's like, oh yeah, because we use Bullet, it feels the same as all the other Bullet, physics games, or because we use Bullet, it doesn't really fit for our game. It should work. But we shouldn't. It should be basically just the basics, just the core of like, is this touching and where should this move to resolve. So that's the idea. So currently, what I want to do is changes from returning the resolve position itself and just make it instead return the resolve displacement, essentially. So that is actually probably a good idea. That's actually probably a really good idea. That might be it. I think it's still shuffling. Yeah. Slow it down a little bit so I can see exactly if this resolves correctly. Yeah, it looks like it does. Okay. Yeah, it's not resolving right. Alright, but that was the good thing to move it there. Actually, I guess it should be... We move it there, and then x equals plus x speed plus y speed. That might be what we need to do. This is float 32. It doesn't like that because okay, just do like this plus x speed. Okay, there we go. Yo, no. Alright, well that was what we need to do for X, but yeah, Y doesn't work correctly. Let's see. Yeah, that's not right for Y. Oh. That might be part of it. Okay. Yeah. No! What? Oh, it froze? That's nice. It froze, I guess because... and 0. You said X speed has a syntax error? Where? Greater than 0, less than 0. Greater than 0, less than 0. Oh. Oh wait, no it doesn't. Might be. Oh no, no problem. Yeah, it's kind of weird that yeah, left works, right works, up no, up doesn't work. Okay, so up also freezes. So what exactly is happening here that it doesn't work? Let's see. This is gonna be fun because it's gonna spam my console, but don't really have too much of an option. Let's see. Let's just slow it down, I guess. 14. Okay. So other shape equals other. Okay, but then it loops around, and how does it? World, let's see. It just sets it to 15. I don't get it. Let's see. Let me make sure that I'm not. Okay, good. All right, so I am. I just want to make sure I'm closing the actual game. All right, let's see. So the prime is y. If y speed is greater than 0, we minus. If it's less than 0, we plus. So let's just like comment that out. So that's not part of it. Let's see. 15. So why does this? If x speed is greater than 0. Let's see. Minus plus. This is an interesting situation. If first jet is colliding, it just turns to 15. Let's see. So, okay, let's see. What's y speed in situations where this is freezing? Is it 0? It's -3. Okay. I'm just trying to like understand exactly what's going on here because it's like okay, so now it works. What? 15, 16? Okay, that's yeah. But when it's doing this, it doesn't like it. Prime x. Wait a second. Prime x is true if y speed and. Oh, that's why. Whoops. So basically. I see. Okay, that was my mistake. We have to do this. Alright, let's try that. Okay. Good. Alright, good. There we go. Yo, we good. It's working. Cool. Alright, well, that's basically it. I mean, at this stage, this is a little awkward, but that's kind of to do with this. I wonder if this could be cleaned up a little bit. Let's see, get xy, set xy, x equals float plus x speed. So I guess I could just add x speed to get xy, couldn't I? No, so it gives you an int 32 x speed plus the set xy. Okay, plus. Yeah, I guess it's about right. And then prime x is true. We get the float. We set the float to be this. If the values aren't, but then we say, oh, what if like y speed is greater though? So then we do that. Colliding. I guess what we could do rather than that, we could just do like for out.colliding. So then we just say, wait. For not out.colliding, we say if shape is, no, wait, never mind. Because yeah, we have to basically determine like, oh yeah, is it colliding anymore? And if not, then we say it's false, and then we're good. Okay, so I think I got it. Ginin Yamouth says, or Yamut. Ginin Yamut says, hey, my first time here. Are you using a framework? Hello. Framework? No, I'm making the framework. Haha. Basically. So basically, what I'm making here is a physics, well, not really a physics framework. It's more of a collision detection and resolution framework. So it just like allows you to easily like smush shapes together and not have them face through each other, which is kind of important for games. And it's kind of weird that there's no such framework, as far as I can tell. As far as I know, maybe there is. That'd be nice. That does this, because this is kind of like basic. Like every game does something like this. I don't know why it's not. There's not a framework that does this. Here's a better example that kind of shows this. This blue square, it just automatically bounces around and basically just doesn't phase through stuff. That's it. And the actual physics isn't what this library does. The library just makes sure it doesn't phase through stuff, essentially. So it just makes things solid, essentially. The actual physics is just a really simple couple of lines here. That's what makes it bounce. I just make it say it has some gravity. I handle gravity, and then I say, hey, you know, if you basically are going to collide with something, then like move to where you would no longer like be inside of the thing, and then reverse your speed. Otherwise, if you're not going to collide with it, then you're good to just, you know, apply the speed that you would apply normally. So it's really just like really simple. I try to make it like super duper simple, really simple and easy, and make it something that, you know, people can use to make their games, and not something that's super super like hard. So yeah, I wanted something that basically it's not a physics engine where I make the physics, or you know, the engine makes the physics, but rather something that allows you to make the physics, and that just kind of allows you to actually have it work. Let's do something kind of cool and make it so that you can actually add more squares. So we're gonna make a list, an expandable list of rectangles, pointers to resolve rectangles. Okay. Oh. There we go. What? Can't make type. Oh. A list of pointers to rectangles. There we go. Then what we're gonna do is say rect equals this, and actually we're gonna make a function that does this. Make new balancer. So we add the space to the shape to the space, and then we say, we don't actually have to do this. We just do that because we probably want the bouncers to bounce off each other, and that's going to be pretty tough. So I want to try that. So then we just say squares equals append squares rect. And then we just do this. Or actually, this won't work because we need to have individual speeds for each of these rects. I guess we'll just do like speeds because I am lazy. We'll make a thing. Type bouncer struct rect resolve rectangle pointer. We got speeds. All right, and then we're good. Let's see. Joel Williams says, okay, wait, Victor Necromancer gives $2 Russian. Hey, thanks, man. Thanks a lot. I appreciate that. Really. Thank you. Joel Williams asks, hey, I'm working on a 2D twin stick shooter, and I was wondering how you think of creative elements and mechanics for your games. I'm not a great person to ask because my creativity is not super high when it comes to inventing mechanics. Maybe interesting things that you think would be fun. Just, a fun mechanic in a game. Maybe something different that you wouldn't think of. If you're making a twin stick shooter, maybe the ability to shoot words at your enemies, and the words have different effects, or you can string them together to make word sentences. I mean, that's just like a really basic idea because I haven't seen it done, and I feel like it could be interesting. Like, just come up with whatever, and just like probably something that's you want different, but you also want really implementable, something really basic, easy. You don't want something that's like, oh yeah, it'll take you years to make this, like, But if you could come up, if you're talking about like purely like a weapon or a power, and you want to make a twin stick shooter, then make something that's a little different. Maybe the ability to shoot mines, and you don't have the ability to detonate them. So it's not a twin stick shooter like a conventional one where you shoot at the enemy. Maybe you have to shoot the enemy toward yourself. Maybe you're like a pinball machine or something. So it's like, instead of shooting things at enemies, you have to receive enemies, or you have to roll, like, tilt the game board to push them toward you, and then like rotate your character to face them, and then that's what determines, like, oh yeah, you got a hit. You didn't shoot them, you moved them into you. So that's like an interesting subversion on the idea. So to think of like creative elements, I would just think of like alternatives, I guess, or things you haven't seen done, or ideas from things that exist already. Like pinball machines, or things around your house, things on your desk, animals. Games can be literally anything, so it's not too hard to come up with something. It's just, it can be hard to make it like something fun. Victor Necromancer says, Potato English is ahead. Hello, Loon. I come here to say that I have migrated to Love 2D and I'm having a great time, much more comfortable. Have you heard of this framework? Yes. Glad to hear you're having a great time using a framework, Love 2D, using the framework Love 2D. I have heard of it. It's a great framework. A lot of people love it. A lot of great games were made with Love 2D. But even if there weren't, you could still use it and try to make something cool. And then, other people would be able to see that it's a valid framework and it's cool. But yeah, Love 2D is kind of well known. It works well. People like it. I like it. It's good. It's good. Alright, so instead of being a list of rectangles, this is going to be a list of bouncers. And we just have to make a new bouncer. So bouncer equals bouncer. Bouncer.rect equal. I guess I could just do it like this. Rect is this, and for speeds, where did I actually set the speeds? Here. Oh no! Alright, and then alright, I think we're good. Victor says, thanks for the response. No problem. Mariano says, GitHub/by arena /box2d. If this is, yeah, box2d I'm aware of. Let me pull that up. Okay, yeah, this is the Go port of box2d. Yeah, the thing about box2d is it's a full physics engine, and I don't want a full physics engine. That's kind of the idea. That's the idea, is basically make something simpler, where it's not a full physics engine, it doesn't have friction, it doesn't have gravity, it doesn't have the concept of worlds, it doesn't have a concept of, I mean, like, if you actually take a look at Box2D, if I recall, it's like, hey, a pixel represents, like, I think it's like, a pixel represents a foot, or something like that, like, it's trying to, what's the word? Be a physically accurate physics engine, and that's a lot if you're trying to make Mario. Like, if you're trying to make Mario, you know, it's a lot to do with Box2D. And I think I had a example of something I made, a platformer with Box2D, and it was like, even on, like, let's say you had like 16 by 16 blocks, like, oh hey, also I got Sprite working again. Hello, hooray, that's great. This is the walk cycle I was working on as well. And a character I was drawing. It's always nice. But basically, let's do something really simple. Alright, right, so you have something like this. And these are individual, like, objects, right? So you have, like, a yellow 16 by 16 block, a green 16 by 16 block, a yellow 16 by 16 block. These are just ordinary blocks. And you have something on top like this. Right? It's just a rectangle, and it's moving to the right, like so. The thing that Box2D will do is that sometimes when it's moving back and forth, it'll stop as though it's being stuck on the edge, and you'll do it again and it won't do it. And it's like, it's just because it's not made to really interact at a smooth level as though these things are completely level. It's something that physics engines do sometimes. You can work around it, but it's like, why use a physics engine if you immediately have to start working around it? Like, you immediately start using an engine, and you immediately have to say, oh, let's do this because it won't work right, so we have to make it a capsule so it works like this. We have to use raycast because, you know, it will trip up otherwise. And it's like, why not just not use a physics engine? Why not just do it yourself and resolve the collisions? Because that's really all you want, is the collisions to be resolved. So that's kind of the idea. Is like, let's just make something that's really simple, that just does exactly what we need it to do and nothing more, because we don't need it to do that much. If you're making like a Marble Madness game or something that requires a fully like physical space in 2D or 3D, then yeah, use a physics engine. But if you don't, then don't. Like, that's the concept of doing less with more is something that game developers tend to do, which is just like, and that's, I'm not hating on anybody, but I mean, like, you think of most games that are out today, they were made with engines, they were made with Unity, they were made with Unreal, they were made with you know, lots of these game engines, and you know, the good ones tend to use everything, but some engines come with things that the people who make the game in the engine don't actually end up using. And it's like, well, if you're gonna use, like, why buy the engine or use the engine and then throw out 100% of it almost? It's like, well, why not you just start off with less? And I feel like you start off with less, you have to do maybe more work on your end, but you end up with something that's lighter, you end up with something that's simpler, you end up with something that maybe you don't have to do more work because you don't have to throw stuff out, and you know how it works because you made it. That's kind of the idea. So anyway, you know, not trying to hate on anybody, but it's just like, you can do more with less, rather than trying to do less with more. Okay, so where are we at here? Okay, we were in the middle. Okay, right. So bouncer, okay, so we're adding bouncers to the list. So then we just need to loop through for blank and bouncer in range bouncers for squares. Bouncer at speed y plus equal. Alright. Wait a second, what did I... Oh, just the... yeah. Alright. Alright, I think we... I don't think that's right. Let's see. Oh, I see. This needs to be a list of pointers to bouncers. Hold on. Alrighty, we're back. That's right. Alright, so I think that should be right? Let's try that. Alright, now it's bouncing. Cool. Alright, why isn't it green though? Blue. Let's see. If rect for shape and space, rect equal to, oh yeah, it's not main square, is equal to rect dot eta. Let's see. There we go. Cool, okay, now we're good. Alright, now... Alright, so we still have time powers, that's nice. Now I want to add the ability to press a button and add more bouncers. So we say if keyboard.key pressed SCL.key up make new bouncer. Oh, that's a world function. All right. Cool. 60 FPS, that's good. This actually makes that you can actually hold it down. And my internet died. Great. Hold on. Alright, sorry about that. Internet just went out and it's back. Apologies. Alright, so I think we're good. Let's see. We add bouncers rectangles to the shape space. Oh, but it's not solid. Okay, so let's go ahead and say, oh man, this is a little scary. Let's set the tag for the bouncers to be solid as well. Oh, they can only have one tag. Oh, Oh, I hadn't considered that. All right, let's make it so that you can actually make more than one tag, I guess. Because I mean, you know, sometimes you need tags. So we'll make the tag a like a string of. Wait, how do we? Because if it embeds this, it's not. We have to actually make that tag string. So how do we want to do this? I guess we could make it a. No, it has to be made either way. Alright, what we can do is. Because, yeah, if we did it like that, we'd have to make it like this, and then say r dot. Tag equals make. We'd have to do something like that each time we make a strut. Alright, how do we want to do this? Because I mean, sometimes you'd want multiple tags, right? So I guess one way, well, because you can't just initialize it. I guess we could make. How do we make it so that you can have multiple tabs? I mean, and the thing that I was thinking of was basically you can make it so that set tag takes like that, so it can take multiple strings. But how do we actually like make that work? I guess that'll work, huh? So we have it's basically a list, an array. We set tag, it just puts it right in the tags and everything, and then you say get tag, it comes back. So I guess that means that we don't have to actually make it, right? Wrong type for get tag method. Have get tag string. Let's see. Why does rectangle have get tag? What? Get tag string. Okay, right. So then shape get tag turns an array. That, I guess, or do I have to say like a list for that, or I guess it would be like this. Take it. Thing is string. So then up here. You can take multiple strings for the tag. So can I just try like nil, or it's gonna be a list of strings, so we'd have to see if one of those strings contains the tag. Is there another way we could do this? Maybe we don't have to have a tag list. Maybe we could have some sort of other means of filtering out shapes. I guess I could use the space filtering method. But that just returns a subspace. I guess that works, right? So you could say like sub, basically filter out a space and then check those. Then you don't need a tag. It just takes this shape. So then you can say, because that's what it does. Then you don't have to have this at all. Space.filter. Well, that's an idea. Well, get tag. I guess we could make a function like contains. Yeah, that might be good. We can make a function that says contains. Or maybe just has tag. Get tags, set tags, has tag, and there's a string. For tag, blank tag, and b.tags. If tag is equal to tag to return true. Alright, so we have get tag, set tags, and has tag. Get tag, set tags, has tag. Get tag, set tags, has tag. Resolve, okay. It doesn't like rectangle because it has hashtag bool. Oh, right, okay. So hashtag turn to bool. And then here we can just say instead of this, that hashtag. Doesn't like this because can't use tag. Oh, because it's an array. Okay. Can I expand it? No? Okay. Doesn't like that. Okay, let's see. Hashtag unexpected. Okay, so I want to see if it has a tag, so you can say it's flagging. Oh, I guess I could make it like this, so it moves through all of those. Wait, so hashtag would be if it has any of the tags. Let's see, so in this situation we're trying to make something solid and a bouncer. Get tags, has tags. So I guess has tags would just be a comparison of all of the tags. If it has all the tags, then it does have all the tags, and if not, it doesn't have the tags. When would you want to check to see if they have the tags? So So you collide with something and you want to see if it has tag. Yeah, I guess you might. Like, let's say we ran into something. We say, okay, if res.otherShape.has tags, blah, and def, then we might die, right? So if we wanted to check individually, we could just say def and blah individually. Let's see, hashtags. Yeah, I guess hashtags you don't fill them out. Get tags. There's not really an easy way to see if it contains. I guess contains has tag, because you can just do has tags one after the other, so that's fine. That way you have control over it. So tag has tag. So if tag is equal to t, return true. Okay, so tag is equal to t. Okay, bool. Tag string. Okay, we good. We just want one, and then we come over here. Is colliding. Tag is a string. Okay, we'll just leave that alone for now. If tag is equal to blank, or as tag. Okay. Doesn't like this because hashtag as once has. Okay, so yeah, the interface is wrong, I think. Yeah, I think that interface is wrong. It's supposed to be hashtag, yeah. Okay, let's try this again. Does not like that. Let's see. Set tags. Alright, I think we're on the right track. Set tags. Right, we don't need that. Hashtag bouncer. Okay. Bouncer solid. I guess add tag might be better. But the thing about the concept of adding a tag to an existing shape is that if you add a tag, like adding a tag means that we have to have the tag list in existence. Well, I guess set tags. Well, I guess maybe we could do it like this, tags. That way you can't actually individually access it, right? Let's see, can we actually get in there? Let's see, bouncer rect.tags. Yeah, okay, so you can check to see if it has a tag, set tags that are currently there, or get tags. So maybe add tag would be better. That way you can, because then add tag, all it has to do is just basically say if it doesn't exist, create it. Get tags has to do the same thing, essentially. So what happens if we try to get tags and there's nothing in here? Is it just going to be a nil pointer? Is that what this is going to be? Let's see. It's just an empty list. And I thought it would be empty. Okay, so yeah, if it does, I guess it just must create the list when it's created. I thought that it would be like a nil pointer. All right, well if that's the case, then yeah, we can just do add tag. That makes it easy. Because that way you can add one, but then you have to make it so you can remove a tag. Ugh. We'll just leave it like this for now. Yeah, whatever, that's fine. Get set tags, get tags. I guess it's fine. What oh, okay, yeah, let's not. Wait. Main square. Oh, I messed this up. Because the main square, that's right, because we got rid of the main square. It's not here anymore. Okay, well. We'll just, yeah. We'll just assume, we'll just act like it doesn't exist. Okay. Yo, let's go! That's pretty crazy, man. Oh my goodness! That is bananas! That's bananas! It's not perfect. Things are getting kind of pushed and squeezed around, but like that's as good as I think you could expect it to be. Like this could almost be a fluid physics simulation. Like this is not bad at all, dude. This is bananas. Like this could be a game. This could be a game. Like you have to play one of these characters and you're getting pushed and bounced around and you have to like finagle your way to the exit and you're just like, ah! That could be good. That would be a pretty fun, simple game to make. And the more it gets harder because it's like the more people get created and the more the more people get created, the harder people push you. Maybe the less friction there is on the ground, like if it's ice or something like that. These two are just stuck. This is not bad at all. It's kind of interesting how like everyone on the bottom is moving faster because the people on the top are blocking them. So the people on top are just kind of like leisurely bouncing around, and people on the bottom are just like going nuts because they don't have the space. Like the people on top are just kind of like chilling, and the people on the bottom are just like, oh! This is amazing. I love it. All right, so that's the idea. That works. That works. That works. That works. That works. That mosh. Okay, so what we're gonna do is just get this up and running too. That should be relatively easy. This is yeah. So we'll just do like var main square resolve rectangle. Actually, we could probably just do this. You know what we're gonna do? We're gonna make this. Yeah, we'll just make this. We'll just call it a player, I guess. Well, that's fine. We could just call it make new bouncer and just make it so that it's not a world-specific thing. It can just be run and it will return the reference to the bouncer. Alright, so it returns a reference to the bouncer. It's the squares, the pinned. Okay, so squares. Okay, so then we don't need that. Or I guess. Yeah, we don't need that, I guess, because we already have one. So we could just say squares equals append squares. Bouncer equals make new bouncer. We don't have to do that because it's already added to the space. So then we just say player equals squares 0. If player dot speed x Speed. Speed. What? Speed. Okay. Okay, that's good. We just do this. X. Alright, so then we just do player dot rect player dot speed x player plus squares 0 player rect alright, why will this not work? Let's see, why would I do this? Oh, it's not. Yeah. Cool. Alright, so that still works. That still handles beautifully. Captain Boomerang says, "Rad, man, that would make a fun screensaver, lol. Like the game idea, too." Yeah, thanks. I feel like that could be fun. Rodent says, "Now create boxes that resemble white blood cells." And they eat cells? I'm not sure what exactly. Yo, check it. 10 FPS. Oh! It's just like, it's cool seeing like the like impossible like shots where something squeezes, like just barely squeezes by. Like, there's no way this is gonna make it, and it's just like, whoop! It's like, no way! I'm gonna call this one Bitey. Okay, so let's try the next one. Let's try the other world. Let's get, so the current idea, now that it's working, is it's good. Yeah, this is working well. Alright. Now world 3 is like not gonna work, but oh well, let's see. Alright, that still works. Cool. AFX Entertainment says, SolarLune, it looks like the collision detection isn't releasing data, it just stacks until it slows the game down. Alright, I'll have to check on that. Where are you, have you run the test on, or like, run the game on your side, or where exactly are you seeing that? Alright, that doesn't seem to be any problems. Alright, so let's go ahead and go back to World 1 and see if we can see this. That's weird. Why is 12.3 megabytes? FX is not on your screen, but I can look into it if you like. Oh, no, it's running at 60 FPS. I mean, it's not running at 60 FPS now because it's a ton of rectangles, but yeah, it's running as it should be. Yeah, now it's down. Although, I wonder if 3 is kind of high. Let's see. 3% of my CPU is being given. Let's see. 1%, 0%. Okay. I might need to nail some stuff if I'm, because the reset I have is just a really basic like recreation of the world. It just does everything again. So it runs this create function again. So it creates a new space. It adds shapes to it. These are all pointers. So do I have to nail those out before I destroy them? I don't quite remember. No, wait. But that wouldn't account for the CPU, that would be memory usage. So let's take a quick look back. Okay, so the game, okay, the CPU is rising, CPU is rising, CPU is rising. Alright, so it's using like 100% of one core, almost. Now if I reset, it's back to 60 FPS, and it's down to 4%, okay. Okay. 60 FPS, 7%, 5%. I wonder though, yeah, I wonder why the CPU is so high. It shouldn't be really doing too much. It's just doing this. Squares. Oh, squares. Oh, wait. Oh, okay. It's this. Okay, so yeah, we just have to recreate squares. Okay, I got it. Actually, let's make it here. There we go. There we go. Okay, that should do it. There we go. Now we're back down to 0. There we go. Okay. Good. I guess the one last thing I probably would want to do is... Ifix says, is there a dot destroy function? Sorry if you already figured it out. I have to restart the stream. Okay, no problem. There isn't a destroy function, but there shouldn't need to be one, because Go should automatically garbage collect it as long as I'm not referring to it. So basically, the issue was that I was making the list of bouncers once, and then basically updating, like adding squares to it. And so it was keeping the squares around even after restarting the game. That was one problem. Yeah. Other problem is I can make it slow down at will just by pressing a key. That's might have been what you saw. But yeah, I do that just to make it easier. I implemented that to make it easier for me to like see exactly how the collision resolution was happening. Alright, so it starts to slow down at like 400? No. 265, but that's in this tight room where it has to, like, it's actually trying to resolve those collisions all at the same time. Like, if it was basically 265 objects in kind of an empty field, it wouldn't be an issue because most of the time they'd be moving and not hitting anything. The problem comes in because basically they're trying to move a large distance, or they're trying to move some distance, and then when they do, it has to basically step through and say, are you touching anything? No? Okay. And then move on. But then it also has to check to see if it's colliding with another shape. So, yeah, the filter function then would actually probably be good. This should be used if you're going to be testing a large percentage. Filter filters out a space, returning a subspace of shapes that return true. Basically, you can use this to segment a space and pick out segment space and copy that space. This reuse if you're going to be going to test is a huge number of shapes to simplify. Can be used to lower the number of shapes test by filtering some out. Yeah, it's interesting because like the smaller the area, the harder they have to work because they're colliding more often. Whereas if it was a bigger area, then they wouldn't collide nearly as often, and so the game wouldn't have trouble keeping up. It's an interesting idea, interesting concept and problem. Alright, well, that's about it. I'm pretty happy with the result that I reached today. Not a lot was this isn't a super long stream, but yeah, it's been going for a couple hours almost, and this is looking better and better. I think the only thing that's kind of like a step back, in my opinion, for this project currently is the let me see here. Yeah, the only thing that's kind of a step back here is that the resolve function now like returns the actual x and y position rather than the distance. I feel like the distance would have been better, but I don't want to have to. I don't want to add in any unnecessary like calculations and things and room for error. I feel like this is more precise and therefore it's a little better to just have the x and y value directly of like, oh, this is where you should move in order to avoid, you know, walking into something. I like that, but at the same time, it's like, well, it's kind of tough, kind of annoying. I'm gonna make this so that you can check for multiple tags. Tags. T1 is equal to T2, return. Yes. Not equal. True. Return all. Okay, so that's good. Now we can. So yeah, to be honest, it probably would be better to like take out the ability to resolve with the tag and just allow you to use filter to filter it out, and maybe make another one to filter by tag, so you have like a space of just solids, and then you go ahead and I don't know, how do I feel about that? Because I mean, keeping the tag system in there the way it is kind of, it's a little awkward. Yeah, I guess that might be better. Let me see how that would look here. So, space. So space equals this, so I would say something like solids equals space dot filter by tag, I guess. And then like solid. Or I guess I could just do filter and then do like a space or shape, best shape. Something like this. This is a little awkward. But I do like the filter. Yeah, I guess I'll make it so that you can filter, because otherwise it's gonna loop through and say, hey, does this have a tag? If your tag is nothing, or if the other has a tag that you specify. So it's already filtering. This is the same as just doing this, right? So you filter through the shapes and then see if it's true. This filters through the shapes. Yeah, I think that this might be better to take out the tag system there and just leave it the way it is and just do like that. Resolve. So then you just filter it out and then move from there. So I guess I'll just make another one specifically for filtering by tag, since that's something that you'll probably do a lot. I guess I could just do that, essentially. Yeah. So then we don't need a tag. Yeah, we don't need is colliding. Yeah. It's colliding. So I guess you could take this out. Well, this could return a shape actually. The other shape. Return that other shape. Turn other shape. Okay. Alright, I think I'm on the right track here. Afix says, I tend to work with pure OpenGL and C++ these days. Oh, that's cool. It's cool that you, I mean, you know, I can understand why you would work with just kind of the basics. It's kind of fun to just work with, like, really basic stuff. And not have to worry too much about, like, what other... I mean, just, like, working closer to the metal is kind of nice. Alright, so... I'm wondering if this is even useful to, like... do you need to test if the shape is colliding with another shape? It's not that useful. I guess I'll leave it in, just because, you know, it would allow you to check to see if it is colliding with something else. It'd probably be better to return a list of shapes that's colliding with. Or maybe a space? So you can kind of like simplify this. So you could say like this could give you a space consisting of shapes that a shape is colliding with. All right, I'll leave this alone for now. For now, I'll just take this out. So we have clear, we have add, remove. Okay, so we got resolve. That's fine. Filter by tag. S shape. Has tags. True. Oh. Return true. Else. Return false. Can't use that as type string as oh, do I have to expand that out? I didn't like that. Can I do like that? There we go. Cool. Guillermo Stancanelli says, "Hey SolarLune, will you not use Godot anymore?" Probably not. I mean, not anything against it. I just don't. I like using. I like coding, I guess. I want to do it myself, I guess is the idea. I guess that's the feeling I have. I don't know. Nothing against Godot. It's a good engine. I would recommend it. I wouldn't say that I won't use it again. I'm not interested in using it at the moment. Just not right now. I'm not really interested in using it like right now. But there's nothing wrong with it. I wouldn't recommend disregard it or say other people shouldn't use it. Okay, so let's try this. So this is going to be a little bit different. We're going to do it like this. Alright. Alright, so Guillermo says, "That's great. I'm not a very proficient scripter, so I think Godot is right for it. For me, yeah, that's good. That's good. I would recommend heavily Godot to anyone who wants to make games and not really worry too much about the engine itself, or even if you are interested in it, like, you know, love 2D, you know, simpler engines like that, simpler frameworks, yeah, please try them out. That can definitely work. It's definitely not a bad idea at all to use simpler things. Alright, so we're back to the basics. So this is gonna... Alright, it still works. Why did it turn white though? Has tags bouncer, set tags. Bouncer, solid. Okay, so one of them is bouncer. Okay, so rec.has tags. They're all false. Let's see. So has tags isn't working. Has tags. All true. For T1, for T2. If T1 is not equal to T2. What is T1 and T2? These aren't the numbers, right? These are the solid and bouncer, bouncer and bouncer. T1 is not equal to... Oh, okay. So basically, I guess I need to do it the other way. Like, if you're looking through the list of tags... Right, I think we want to do it like that. So we say... Okay, wait. So basically, we gotta make this a little more easy to read. Okay, so we say, okay, we're looking for through the list of tags, right? So we have like tag A, tag B, maybe just one tag. We can do T1. So it says, okay, we're looking now and seeing if we can find it. So I guess we want to go like this. That sounds good. So we want to say found false, found true, continue. Well, if not found, has tags false, break. I think that's right. Let's see. Alright, cool. So now it looks like it might work. So we'll say fine bouncer dot bouncer dot rec dot has tags. Solid false, solid true, bouncer true, bouncer false, okay, bouncer solid true, solid. Okay, so, but now if we misspell one, it's not gonna work because it doesn't have those tags. Okay, cool. Alright, I think we're good. Well, that's working. Yeah. So now we don't need this. Okay, so this is going to be a little different because basically now we might actually, I think in this example we actually do have solids, and yeah, so this is like you're not able to go into this zone because it's not solid, but we are testing against the actual space. So if we want to try to filter this, we would say solids equals space.filter by tag solid. Wait a second. Solid, yeah. And then we can just say solids.resolv. Nice. The only downside of this approach is, I guess actually filter by tags would be better. The only downside of this approach is, well, it's the same thing, right? It's the same thing as we had before, where it was saying for each shape that you're checking against, does it have the tag? So this is just doing it beforehand. It's saying for each shape, does it have the tag? It just makes another space out of it. And the space is just a collection of shapes. So it should be pretty lean. It should be pretty lean. Right? Filter is does the shape have the tag? Because we're actually doing two tests. Because one was if it was if the tag was blank, and the other one if the tag is it, if it's got the same tag. Now we don't do either of those. So in cases where the shapes had tags, it was doing 2 extra checks. Now it's not doing any of those. It's just doing the one to see if the shape is the same or not. All right, I think we are just about golden. As tags, resolve, okay, we solid. Yo, cool, really nice, really clean, really nice, really fun. The only last thing I need to do is just update the README, because this is not up to date anymore, assuming that we keep this. And I still am not sure about, well, I guess I'll keep it the way it is with the resolve x and y being exact, because I mean it is exact, that's nice. Actually it should be, in this case, first shape.x, or no wait. Yeah, first shape.getXY. Dot resolve x plus equal 832 x speed y. Okay, I think that's right. And set x y. Cool. V cool. V cool. John Hamilton says, hey. It's not perfect. It's not perfect. There's weird stuff going on when it looks like they reach high speeds. They're just kind of like forcing themselves into locations. Let's see. It's probably because of the for loop. It might be better to make it so that they don't like force themselves to resolve in locations and directions and things should something happen. Because I mean, I guess it's also possible because the resolution is just one pass. So basically, if the situation can arise where it's like if a rectangle moves into a position after a resolution and another rectangle moves into another position after a resolution, it can happen that they just don't leave each other any recourse. Like if there's a rectangle here and there's a rectangle here, and for whatever reason this one resolves here and this one's heading right. Or I guess a better example might be, we'll just do something simple, like let's say there's a wall here, so this one resolves here, this one's heading really fast and resolves maybe here on the other side of the wall, but then another cube comes in and comes here. I mean, you know, things can happen where basically they go all over the place. Like, it should be that one cube resolves against another cube, but then if that other cube, like if this cube for whatever reason resolves here, and this cube for whatever reason resolves here, well, I guess the example I'm thinking of, I can't really think of it, but essentially it's possible for a cube to resolve against a cube that's already resolved. So like if this one's resolved, and this one resolves, let's say somewhere here, now they're intersecting. So that can happen. So I could do it, you know, run another pass, but that's ridiculous. I think that it's just, you know, they're gonna be moving really fast, they're gonna bounce into each other. I guess, you know, one thing you could do is basically resolve the other one should you collide. Well, that's, I guess, unnecessary, because if you resolve the one moving cube, then the other cube, it does, the other, you know, if you, let me see, if I can pull that out. So if one cube moves into another one, it should already be resolved, essentially. If one cube moves into another one, then it's already resolved, and so if it's already resolved, if this one resolves, well, use a different color for this. If this one resolves here, then it's resolved. It doesn't really matter if the other one's moving or not. The other one might move elsewhere, but this one's still resolved. So I guess what I need to do is, I have to think about it. I gotta think about how I want to approach this specific situation. It's not perfect, but I don't know, it might just be a kind of what's going to happen at high speeds. They're just going to do stuff like this. This cube refuses to let anything get out. It's just in the worst location. Yeah, there's definitely some weirdness going on when it comes to high speed stuff, because it has to resolve somehow. And if a situation comes up, I guess, where something's above the cube, and it needs to resolve upwards, it's going to basically just shoot up. If it says, oh, I need to resolve up, then it's not going to be able to. And it's just going to keep going up. So I guess that's probably what it is. That's probably the actual problem I'm thinking of and I'm running into is a situation where there's 2 cubes. I guess there's 3 cubes. And it's something like this. So this rectangle goes right, it turns around, right? So now it's gonna be moving left, but there's a rectangle here already. Maybe it's falling like this or something like that. So the left rectangle, this rectangle says, okay, I need to resolve left. I'm trying to move left. Or I guess a better example would be something like this, where the cube got into this position by bouncing left. So essentially, this blue cube got here by falling in like this. And so now it basically says, okay, I bounced left, now it's time to bounce right. So when it bounces right, it says, oh, I'm touching this cube, and I'm trying to be here. And so it's, how do I move back? So it starts to move back, but maybe there's something here on this frame. And so it has to go all the way over like this. So then now the question is, how do I handle situations like that where basically in one frame it's no longer physically possible to put it where it was. Currently it's gonna keep moving left until it resolves. So I might say like, oh, if it's over 16, don't worry about it, or something like that. So in situations like that where it's like, oh, I need to move left, oh, there's nowhere to move left, I'll just be here, that's fine, rather than teleporting. So that might be something that I want to implement. So yeah, that might be where the distance comes in, because it's like, okay, I might make it so that basically either you can give a margin of saying basically just ignore it at this distance, like after 16, just, don't even return a collision, or maybe the collision has a variable that describes basically how far it goes, like distance or something, so you can see like, oh yeah, it's 16 above 16 pixels, so I'm gonna jump 16 pixels to go back, or I'm gonna jump 48 pixels to go back, and which is like, just forget it, I'll just be inside the thing. That's fine. Alright, well, that's fun. It works. It's good. I'm happy with the filtering idea. It works well. I think this is fun. I think it works. It's fun. It's good. It's nice. I like filtering the world down to make smaller worlds to actually test against. I think that's cool. It's a cool idea. Alright, well, I'm good. I think I'm good for now. Thank you very much for watching. I've been SolarLune. This has been a fun stream where we sit around and do physicsy kind of stuff, but not really. And hopefully next time we'll have something even better, and I'll have something cool to make. But yeah, this is cool in itself, and I think that it's a lot of fun to mess around with, and I think it could be really useful for my future games, and maybe other people's future games too, if they make things that require physics at all, and they don't want to use a full physics engine. I think this is a nice compromise in a sense that just kind of like lets you work. Alright, well, thank you very much for watching. I've been SolarLune, and I'll catch you guys on the flip side next time, and yeah, thanks for coming by. If you want to check out my other stuff, please feel free to check out the description. Lots of cool stuff in there. Steam, Itch, Bandcamp, lots of stuff that I made on different platforms. So thank you very much for watching, and I'll catch you guys on the flip side. See ya.